Hi, today I'm going to be showing you how to print the words Hello World to the screen in MASM 8086. Well, first of all, I'm using Notepad++. You can download this at notepad++.org. The pluses are in words and there are dashes between them. Right, so first of all, we're going to start off by writing out our two segments, the data segment and the code segment. Well, basically a segment is more of a section. So there are two sections of code which you'll always have to have in your MASM 8086 in every program that you program. So first of all, we're going to write out data. You don't need to write it out in capital letters if you do. I just prefer capital letters. Right, so first of all, data is the name of the segment and the directive segment, and we're later going to use the end directive, signify the start and the end of a segment. Right, so then we're going to, in this, oh boy, and in the segment we're going to assign our variables. So all your variables are assigned in the data segment, and in the code segment is where you're going to define all the code that you're actually going to run at the end of the day. So first of all, I'm going to have a variable called MSG. You can call this variable anything that you want to call it, just keep in mind that you're going to have to use that name later. And then I'm going to assign a type, which is db. And db, it means defined byte. Basically what it says is that the computer is going to reserve one or more bytes of space for the string that you're going to use, and this is normally used for a string of which all your words can fit into one line, of any length, of course. The other things that we may use is DW, I think. DW, well, what you can do with DW is you can basically store two letters of a string. Well, not more than two letters of a string. So in this, we're going to write out our string, Hello World. And I'm going to put in an exclamation mark, and then I'm going to end off with a $sign. What this does is it terminates the string, so it just says that is the end of the string, because otherwise you're going to have a whole load of other gibberish when you run your program. Right, and now I'm going to end this data segment. Right, and now we can begin with the code segment, because that string is, well, basically all that we're really going to use. So I'm going to write out the code segment. And then the next line of code is assume. This is a directive, which I will explain just now, as soon as I've written this out. Okay, the assume directive is used to assign logical segment to physical segment at any time. What it basically does is it tells the assembler what addresses will be in segment registers at the time of execution. So basically what this assume directive does is it tells the assembler that the CS register will store the address of the segment called code, and that the DS register will store the address of the segment called data. Okay, so now we're going to start off with our first label. Your label, the first one's called start. What it basically does is it's just a pointer. So it allows you to jump from specified sections, between specified sections. Right, and these two lines of code that I'm going to type out now need to be in every program. What they basically do is initialize your program. Right, so what this says is that you're going to move everything that's in data to the AX register, and then you're going to follow up with everything that's in the AX register. You're going to move it over to the DS register, and I'll explain in later tutorials why we don't just put data directly into DS. Right, so the next 3 lines of code are going to display our message. So you first start off with move AH 09H, right, now I'm sure you've spotted the interrupter with 21H. I'll explain in later tutorials what that basically does, well, in more detail properly actually. Right, so first of all, this line of code, what it does is it takes the number 9 and stores it in the AH register in hexadecimal format, and then LEA takes the address of MSG, which is our variable over there, and saves it in the DX register. Right, and then we have the interrupter, of course. So this basically prints out our string. So I'm just going to type it out over here in a comment, and this is how you do a comment in MASM 8086. Right, and now we're going to type out another label which is called stop. You don't need to type this label out, I just love being pedantic. Right, and then what this following 2 lines is going to do is it's going to terminate our code, and because you need to end your program, of course. So we're going to type out MOV X and then 4. H. Right. And what this basically does is it takes everything that's here, it takes that number, which is obviously a hexadecimal number, and moves it over to the registry AX. Right. Also, when you're typing out numbers, have the H if it's hexadecimal, B if it's binary, and nothing if it's decimal. And then I'm going to put an interrupter here for 21H. Right. So clearly we have 2 interrupters in the program, one over here, one over there, and then yes, that's basically about it. So now we're just going to end the segment, the code segment, and then we're going to end the start segment. Right, and that is just about the code, all the code that we need to print Hello World out in MASM 8086. Right, so I'm going to save this, and I'll save it. Right, I'm running a 64-bit, you see, a 64-bit Windows 7, so I'm going to save this in the directory with my 16-bit MASM. So when you save this, I'm going to save it as that. See, I already have one. I'm going to save it as hello or hello2.asm. And remember that when saving this file, as an ASM file, you need to go over here and either choose ASM, or if you're using Notepad or anything else, then you just choose all files, so that you can change the extension to anything other than txt. So I'm just going to save that code, and then I'll have a video later for running the code.